This is Chapter 10, Section 2, Problem 29. The contingency table below shows the results of a random sample of motor vehicle crash tests by age and gender at a level of significance of alpha equal to 0.005, form a homogeneity of proportions test on the claim that the proportions of motor vehicle crash tests involving males or females are the same for each group. So let's take a look at this information bar here. Another chi-square test that involves a contingency table is called the homogeneity of proportions test. This test is used to determine whether several proportions are equal when samples are taken from different populations. Therefore, populations are sampled and the contingency table is made. Sample sizes are determined. After randomly sampling different populations, you can test whether the proportion of elements in a category is the same for each population using the same guidelines as the chi-square independence test. The same guidelines as the chi-square independence test. The null and alternative hypothesis are always the same variation of these statements. Some variation of these statements. The proportions are equal, or at least on one of the proportions is different than the others. Okay. Let's see here. So let's take a look at finding critical value here first. So for this one here, we're interested in what's going on from the right. Degrees of freedom is going to be rows minus 1 times columns minus 1. So that's going to be 1 times 1, 2, 3, 4, 5, 6, 7, 7. In this case here, and there's a critical value. So in the red is where your test statistic lands in the red, then we actually end up rejecting the null hypothesis. If it falls in here, we fail to reject the null hypothesis. Okay. So now let's take a look at finding what the actual test statistic would be. So you see there's a critical value at 20 there. So our test statistic stat tables, contingency, summary, stat tables, there. Chi-square test for independence, and I hit compute. And there's our test statistic there. So our test statistic is low compared to the what we found to be the critical value. It's low enough to conclude that the proportions are the same. The proportions are the same, so we fail to reject. It falls in that region where we fail to reject the null hypothesis. The proportions are the same.